Example 6. Find a formula for f inverse and give the domain and range of both f and f inverse. Then sketch both functions on the same coordinate axes. The function for this example is f of x is equal to the cubed root of x plus 2 minus 5. As I did in example 4 and example 5, I am going to start by graphing this function, okay? This is also a transformation. The parent function is the cubed root of x, and since we are adding underneath the cubed root, okay, remember the cubed root acts like parentheses, so the x plus 2 is trapped, so think of it as parentheses. If you're adding inside parentheses, you are going to go to the left, and then the minus 5 on the outside, that means we're going to go down 5. Okay, so let me write here, the parent function is x cubed. It is moved left 2 units and then down 5. Okay, so that's what we're going to try to graph here. So I'm going to first draw with x's the points on the parent function. So x cubed goes through the origin. It goes through 1, 1. And this is, okay, it goes through 8, 2. Okay, because remember this is the cubed root function, not x cubed. Okay, it also goes through -1, -1, and then it goes through -8, -2. Okay, so those are points on the parent function. And so now we need to take each of those and move them left 2, down 5. Okay, so left 2, down 5. All right, and then here, left 2, down 5. Okay, so just give me a minute. I'm going to do that to all of them. And these are going to give us the points on this original function. Okay, so one more. So left 2, down 5. Okay, and since to avoid any confusion, I'm just going to erase these x's. Okay, and then I'm going to connect the dots with the same type of curve as x cubed would have. So it's going to look like this, kind of like that snake graph. We always said it was a snake shape. Okay, so this is the original function. Okay, all right. The domain is all real numbers. It covers the entire x-axis. Okay, also think back to your domain rules. If you're getting the domain from the formula, cubed root, the domain of a cubed root is always all real numbers. Okay, now this snake, remember the snake goes down very slowly. Eventually, it'll get to negative infinity, and it climbs very slowly. Eventually, it will get to positive infinity. Okay, so the low point will be negative infinity. The high point will be positive infinity. Okay, so domain and range are both all real numbers. Okay, all right, let's go and get the inverse function. Okay, so let's go ahead and change f of x to y. And then in the next step, we will switch x and y. Okay, so I'm going to get x equals the cubed root of y plus 2 minus 5. Okay, so now we want to isolate the y. Okay, again, you want to make it look like this. Okay, I want to solve for y, and on the other side, I can only have x's, no y's. Okay, so the y is trapped in the cubed root, so you want to get this guy, whatever contains the y, you want to get it alone, so we need to first move the 5 over. So we're going to get x plus 5 is equal to the cubed root of x plus 2. Okay, sorry, y plus 2. And again, we're after that y, getting it isolated. Okay, the y plus 2 is trapped in the cubed root. So in order to undo a cubed root, you're going to cube both sides. Okay, so remember, this is a package deal. That whole side gets cubed, so you need parentheses there. Okay, so on the left, we're going to get x plus 5 cubed is equal to, on the right, the cube and the cube and the cubed root cancel each other, so we're left with y plus 2. Okay, and then finally, if we want the y, we need to just subtract off the 2. Okay, so we're going to get y equals, in parentheses, x plus 5 cubed minus 2. Okay, that is your inverse function. Okay, all right, I'll even write it up here just to be clear. The inverse function is x plus 5 all cubed minus 2. Okay, all right, so let's go ahead and graph this guy. Okay, the inverse function. This is another transformation. Parent function, x cubed, and we're going to, since we're adding inside parentheses, we're going to go left 5, okay, and then we're subtracting 2, so we're going to go down 2. Okay, so let me write that down. So this is going to be parent function of x cubed. The plus 5 in parentheses means we go left 5. We're going to do that first, do the parentheses first, and then the minus 2 outside of parentheses means we go down 2. Okay, so I'm going to go ahead and put little x's to denote the points on the parent function x cubed. X cubed goes through 0, 0, 1, 1, 2, 8, and then it also goes through -1, -1, and it goes through -2, -8. Okay, so each of those guys, we need to go left 5, down 2. Okay, so left 5, down 2. Okay, and then let's see, where's my next one? Left 5, down 2. Okay, left 5, down 2. Left 5, down 2. Okay, one more. All right. Okay, so I'm going to erase my x's so don't get them confused with the other graphs that are going on here. Okay, so my little dots here, I'm going to connect with an x cubed shape. So remember, x cubed is the long S shape. Okay, so it's going to look like this. Okay, so this is the inverse graph right here. Oops, make that a little clearer for you. All right, so that's the inverse graph. Okay, so I'm going to go ahead and draw in y equals x, that line. Okay, again, y equals x is just the line where the x coordinate is equal to the y coordinate. So it goes through the origin, 1, 1, 2, 2, 3, 3, and so on. Okay, both the original graph and the inverse should be symmetric about this line. Okay, if you fold your sheet of paper along this red dotted line, the graph of the original will lie on top of the graph of the inverse. Okay, so this is the line y equals x. Okay. All right. And you can do a little check here, whatever is on the original. So if you take a point on the original, this is 6, -3. Okay. If you flip-flop those points, you would better see that on the graph of the original. Okay. So if we switch the x and the y coordinates, -3, 6 should be on the inverse, and it is right here. Okay. And I won't go through all the points. Maybe I'll check one more. This is -3, -6. You flip-flop them, you should see -6, -3 on the inverse, and you do. Okay, so this is all making sense. Okay, last thing we're going to do is we're going to write down our domain and range of the inverse. Okay, so the inverse, you can look at the graph. It's a very steep decline, okay, but it does go down forever, and that corresponds to these x values, and it does go up forever. That corresponds to these x values. Again, when you're looking at the function, there's no square roots, there's no fractions, okay? So the domain is going to be all real numbers. Okay. Should be pretty clear that the range is all real numbers as well, because the low point is negative infinity and the high point is positive infinity. Okay. And it is very true that the domain of f is equal to the range of f inverse, and the domain of f inverse is equal to the range of f.